Hey guys, welcome to Techie DIY. In today's video I'm going to look at the FoxAlien HW40 hot wire foam cutting CNC machine. This uses an 0.25mm diameter nichrome wire to melt a path through the foam. The wire is heated by connecting it to a power supply. This is a Gerbil based machine with 2 axes and a third rotary axis. It can cut different types of foam by setting the wire voltage and the axis speed. This is what comes in the box. It's fairly easy to assemble, with full instructions provided in the user manual. First, the base profiles are screwed together. The feet are screwed into the base frame. The rotary axis profile is attached to the base. Clamps are slid into the clamp profiles, and the clamp profiles are attached to the rotary axis profile. Next, the gantry sides are attached, followed by the gantry top. Next, the nichrome wire is installed. The knob is used to tension the wire and expand the spring. The purpose of the spring is to compensate for the wire lengthening as it heats up. Finally, the wiring loom is installed. The connectors are labelled for easy identification. Now the power lead is plugged in and the USB cable. Check that the emergency stop switch is released. The mains power is turned on, and then the switch is pressed to turn on the hot wire. Adjust the voltage to set the temperature. Next, we're going to look at the software, but before we do that, a quick message from today's video sponsor. PCBWay are best known for their high quality, affordable, rapid manufacturing services, including CNC machining, 3D printing, sheet metal fabrication, injection moulding, and of course PCB design, manufacture and assembly. Prototype PCBs are available from $5 for 10 units, and after moving into a new factory with increased production capacity, PCBWay are offering a price reduction of up to 20% on 4-layer and 6-layer PCBs. To get a quote, just select the process, select the material and the options. PCBWay is a one-stop shop for your project needs. For more information, check the link in the description. The software, PDF and example files are provided on a USB memory stick. The USB COM port driver should be automatically installed by Windows. Inkscape is used to design and create G-code files, and UGS or Uniform G-code sender is used to send the G-code files to the machine. Both of these are free and can be downloaded directly from their respective websites. UGS is copied onto the computer hard drive, and the UGS platform.exe or 64 file is run from the bin directory. Once it's loaded, the firmware is set to Gerbil, the correct COM port selected, and the connect button pressed. The home machine button is selected, and if all is well, this should initiate the homing cycle to find the machine's 0 position. The user manual gives some good instructions about how to use Inkscape to create designs and turn them into G-code. I'll quickly run through an example of importing an image. Shift-Control-D opens the Document Properties menu, where we can set the width and height to 400mm. And then in Edit, Preferences, Interface, uncheck Origin at upper left with Y-axis pointing down. Control-I to import an image. Click the padlock to lock the aspect ratio. Then we can change the width of the image. Shift-Alt-B is used to open Trace Bitmap. This traces the outline of the bitmap and turns it into a separate path. Now we can delete the original image. Set the position. Set the display mode to outline. The image trace created several separate paths. Some of these are not required, so they are deleted. And that leaves 3 main paths, which I'm going to join together with a rectangle. The rectangle object is converted into a path. Now I'm going to add another rectangle to extend the path out to the edge of the page. Turning on snapping makes locating the rectangle easier. Convert that into a path. Then we can join the path together with the union command. Now we have one single continuous path. To set the path start position, double click the path to show the nodes, select the bottom left node, and then select break path at selected nodes. And then use Shift-Control-S to save the design as an SVG file. To cut the design on the Hotwire machine, we need to create a G-code file. From the Extensions menu, G-code Tools, Tool Library, select Cylinder, and Apply. Select the Text tool to modify the parameters, change the feed to 800, and the penetration feed to 1000. Select G-code Tools, Orientation Points, set the Z depth to -1, and then G-code Tools, Path to G-code. Under the Preferences we can set the G-code file name and directory, and then under Path to G-code select Live Preview. Ignore the message and apply. If the path is covered with arrows, then it has worked and created the G-code file in the specified directory. Now that we have a G-code file, we can open it in UGS. Set the appropriate voltage for the foam material that we're going to cut. Clamp the foam in position. Reset the axes to 0. Turn on the hot wire. Send the G-code to the machine. And when the job is complete, turn off the hot wire. Next, I'm going to use Slicer for Fusion 360 to create a design from a 3D STL file. The software is no longer supported, but you can still download it. First, the STL file is imported. Then the material is selected. The units and object size are selected. And then the construction technique. There are some really interesting options. I'm going to use interlocked slices. The number of slices are increased to fill out the model. The cut layout is on the right. Red designates an error. To fix the error, Modify Form is selected, and the model thickened. To save the cut layout, Get Plans is selected. The file type is set to DXF, and finally Export to Computer. Now we can import the file into Inkscape, delete the unwanted text, rearrange the parts and connect them together with rectangles so that we end up with one continuous path. The G-code file is created with the G-code tools and sent to the machine from UGS in the same way as before. Finally, the parts were separated and glued together with CA or superglue. Next, I used an online tool to create a model aircraft wing. The tool is designed for use with a 4-axis machine, but the FW40 is a 2-axis machine, which means that the hot wire can only move horizontally, up and down, forwards and backwards. Because the HW40's controller doesn't recognise the 2 extra axes, we need to modify the machine setup by placing a semicolon in front of the U and V. This turns the commands into comments in the resulting G code. There are lots of options, including adding spars and ailerons. Once the G code is saved, we need to make some modifications, manually commenting out the other commands that the HW40 controller doesn't recognise. Once that's done, we can use UGS to send the G code to the machine. Next, the rotary axis was installed, plugging in the Z-axis cable to the stepper motor and attaching the stepper motor to the frame. Then the platform is attached with 2 grub screws. The manual contains detailed instructions about how to create rotary G-code using Inkscape. Before we can create a design, we need to know that the Z-axis is the rotary axis, with 40mm equivalent to 360 degrees, and that X equals 200mm at the centre. So the first thing is to set a guideline for visual reference at X equals 200. Then an image was imported from the USB memory stick. The width was changed to 130mm. A shape path was created with the Trace Bitmap tool. And then the original image deleted. The shape path was then centered on the guideline. A rectangle was created. Resized to be just larger than the shape. And centered on the guideline. The rectangle was converted from an object to a path. Both paths were selected. And the exclusion command used to cut the shape out from the rectangle. Snapping was turned on. Another rectangle was created. And converted into a path. Then all the paths were selected. And the difference command used to remove half of the shape. So this leaves us with one single path, which represents half of the full object. To define the path start point, bottom left node is selected, and then break path at selected node. We can save the design as an SVG file, before moving on to create the G-code. Under the Extensions menu, G-code tools, Tools library, Cylinder is selected. Then the text tool is selected to change the parameters, setting the feed rate to 800mm per minute and the penetration feed rate to 1000mm per minute. The depth step is the number of millimeters that the rotary axis will move each time. Orientation points is selected. Z depth is the total distance that the rotary axis will move. With a value of 40mm, the axis will move through 360 degrees. Then path to G-code. In Preferences, we can set the file name and path. and then under Path to G-code, select Live Preview, ignore the message, apply, and the G-code file will now be created in the specified directory. A thick piece of stock was made from 50mm or 2-inch thick sections of polystyrene with a dab of hot glue at the centre of each. Although the platform has spikes, I also used double-sided tape to attach the polystyrene. The design and G-code was modified to help avoid the glue before being loaded into UGS and sent to the machine. I cut the top and bottom off by manually jogging the machine. And then I just rounded the top off the piece with sandpaper. If I'd used a thick enough piece of polystyrene, this would not have been necessary. For the next Rotary project, I imported an image of a baluster into Inkscape and converted the half profile into G-code. I applied some masking tape to the Rotary platform, followed by double-sided tape, and applied it to the back of the polystyrene. The Rotary platform was then attached to the stepper motor, the G-code loaded in UGS and sent to the machine. Finally, let's have a quick look inside the control box. First, we have a 30V 8.3 amp DC output switch mode power supply. The control board runs Gerbil on a GD32F103, which is a 32-bit ARM Cortex M3 microcontroller. The voltage output to the hot wire is approximately 30 volts, and it is pulse width modulated to control the wire temperature, probably using this 555 timer to generate the PWM signal, and some sort of MOSFET under the heatsink to switch the power. Okay, so I think this machine would be useful for crafting, making props or patterns for casting. It can cut straight sections of model aircraft wing, but for shape wings you would need a 4-axis machine. You can use most CAD and CAM software with it by using a Gerbil post processor. It acts in a similar way to a laser CNC machine, but where the laser doesn't turn off between toolpaths. I'll put the links to the machine and the software that I used in the video description. Hope that was interesting. Thanks for watching, and see you again next time.